Good morning. Happy Wednesday, March the 18th. Today we are going to continue with our unit on energy and discuss the term power. All right, just like the word work, power in physics means something very specific. All right, whereas in regular English we use the word power to describe pretty much anything. We said that the president is powerful, kings are powerful, engines are powerful, right? Or that they have power, a great deal of power, or no power, right? The emperor said unlimited power, right? Anyway, so what we're going to do today is talk about what that word power actually means in physics, all right? So let's get straight to it, shall we? The word power is defined as the rate at which work is done. Now, what does that mean? All right, the actual definition will pop up on your screen in a minute, but the word power means that if you do 1 joule of work, okay, you can do it very quickly or you can do it very slowly. All right, for example, if you lifted a 1 Newton object off of the floor up to a height of 1 meter above the ground, okay, that would be 1 joule of work. All right, like that's what we talked about yesterday in yesterday's video. Today, we're going to talk about how fast we do that work. All right, if I lift that 1 Newton object to a height of 1 meter in 1 second, I will have done 1 watt, or I will have expended 1 watt of power. If I lift that same 1 Newton object to a height of 1 meter in 10 seconds, then I will only have done 0.1 watts of power, or expended 0.1 watts of power. Okay, so I don't know what that just did, so I just wanted to move my ugly mug out of the way of the words there. I think that worked. Anyway, so by definition, power is the rate at which work is done. And notice in the example that I gave you, if I lifted the object very quickly in 1 second, a small bit of time, the power came out to be 1 watt. Whereas if I lifted it very slowly, the power in 10 seconds, the power came out to be 0.1 watts. Okay, and so the faster you work, the more power you expend. Right? The shorter the period of time, the more power is used. It is a scalar quantity, meaning that it does not have a specific direction, and its units are watts, which are named after Joe Watt, who is or was an American scientist. He was actually the inventor of the steam engine, I believe. But 1 watt of power is defined as 1 joule of work done in 1 second of time. So a watt is a joule per second. Okay? It is not a what, which is a question word. It is a watt, which is a joule per second. The formula for power is shown on the bottom of your screen at this point. Power with a capital P is equal to work, capital W, over delta T. Notice the capital W there in the formula stands for work. It is a variable, whereas a watt is also symbolized with a capital W, but it is a unit, not a variable. This brings us to example number 3 in our little adventure here, which says a crane raises a 200 Newton weight to a height of 50 meters in 5 seconds. What, pray tell, is the rate at which work is done? Now, there's a little trick here, because we're asking what is the rate at which work is done, but what is that really asking? Well, oh, geez, hope I ain't got the corona. What is the rate at which work is done? We have, in this case, power, right? Power is the rate at which work is done. So I'm actually trying to solve for power here. So how do I actually go about solving this this problem? All right. Well, now we'll start out by making a laundry list, just like we always do. Okay. the question, or example 3 says, a crane raises a 200 Newton weight. All right, so that tells me that the force I'm going to have to apply in lifting, in raising this object, is equal to little w. Oh my God, another w. All right, this one's the little w, which stands for weight. So in this example, the force equals the weight, which is 200 newtons. Excuse me. The value of delta y, the displacement, in this case is going to equal the height which we've raised this thing to, and that's going to be 50 meters. The change in time is going to equal 5.00 seconds. And so, and then the question obviously is, how much power have I expended here in order to raise this 200 Newton weight? Okay, so a crane raises a 200 Newton weight to a height of 50 meters in 5 seconds. What is the rate at which work is done? So again, I'm looking for power, and I know that power is equal to work, notice capital W in this case, divided by time. And I know from my previous lesson that work is equal to force times displacement, or in this case, the weight times the height, all divided by delta t. So in order to calculate my power, I'm going to take 200 newtons of force or weight, and I'm going to multiply that by 50 meters right here of delta y, displacement or height, and divide it by 5.00 seconds. So that gives me, come on you knucklehead, that gives me 2,000 watts. Notice the capital W again here, different from this capital W, all right? But 2,000 or 2.00 times 10 to the 3rd watts in terms of significant figures, okay? So, any questions about this or how to calculate it, please make sure that you email me at grap@lasallinstitute.org. Your homework for tonight is to go back through your homework sheets. I know most of you have probably already done these problems, but again, I'm trying to get us up to speed with a little practice and a little, work here. Notice the pun. So go through, do examples or problems 4 and 5 on the energy homework worksheet, and I will collect those when I see you in 2 weeks. All right? Be well, stay safe, and may the force be with you.